Hi Math 2. This is lesson 3 out of our math workbooks. It's page 23 of your workbook. So why is it a dilation? Something that we learned in the first two lessons is that if we multiply our x coordinate and y coordinate by the same number, our image is going to be similar to our original. It'll just be a different size. In this case, it would be 3 times bigger. So they're going to ask us to do this rule on this graph. So let's take a look at the first statement. Read this with me. Add these auxiliary points and lines to create two right triangles. Label the origin point P. This is my origin point P. And we're going to plot points M. This is 2, 0, it's M. And N is 6, 0. And now it says to draw the segments from P to B prime. So I'm going to carefully draw a segment from P to B prime. Oh, that was pretty good. And then from M to B, this vertical line, and from N to B prime, so this vertical line. So this is creating two triangles. If you remember our nested triangles, I have the little triangle on top, this little guy that I'm making darker, and then you have the whole large triangle that we see here in the picture. It says, how do triangles PMB, PMB would be the little triangle, and PNB prime, PNB prime, the bigger triangle, compare? So this is the little triangle, and this is the entire large triangle. So it asks us how that they compare. Well, I know that they are similar. PMB, the little triangle, is similar to the triangle PNB prime. And I know this because if I look at my picture, for example, this side is 1, and then this would be a second, and this would be my third. If I look at this side, this is my first. This round in here would be my second. This would be my third. And if I count, then this side is 3, and this side should be 9 then. 1, 2, 3, 4, 5, 6, 7, 8, 9. My sides are all in proportion, and therefore my angle P is shared by both of them. So I could say that my two triangles are similar to each other. What must be true about the ratio of the little side PB to the big side PB prime? Well, it's in a 1:3 ratio. So my little triangle to my big side would be in a 1:3 ratio. Let's take a look at page 24. Page 24 has 4 graphs on it. It says match each image to its rule. So I want to tell you there's been a mistake on this page. If you just want to cross out rule 3 and you just want to cross out B, we're going to be looking at A, C, and D, and we're going to compare that to transformations 1, 2, and 3. So it says match each image to its rule. Then for each rule, decide whether it takes the original figure to a congruent figure, a similar figure, or neither. Explain or show your reasoning. So to begin with, as I'm looking at my rules, I get an idea in my head that this transformation, I realize, is a dilation. This is really dividing each coordinate by 2. I could think about that as multiplying by the reciprocal, so multiplying each by a half. In this first one, my image should be half as big as the original. I'm eyeing this second one. We did this in the first 2 lessons. When I flip-flop my x and y and make one of them negative, it's a rotation around the origin. So I need to look at something that looks like it might have been a rotation. And then here, when I subtract 4 from x and subtract 3 from y, I already know that that's a translation. I'm sliding it around my graph by taking 4 away from each of my x coordinates and 3 away from each of my y coordinates. So looking at my 3 choices here, D actually is one. Well, why don't you take a moment? You can pause this video. Why don't you try to match up A, D, and C with 1, 2, and 3? Or I'm sorry, 1, 2, and 4. Okay, welcome back. So let's see how we did. First of all, this translation, I noticed here F goes to F prime, and F prime is half as big. This side was 2, now it's 1. This side was 4, now it's 2. So it looks to me like 1 goes with D. D is number 1. And it said what to say whether it was congruent, similar, or neither. So this is similar. It's a dilation. So now I look at this particular one. This should be a rotation about the origin where my x, y is going to y, negative x. So I look at my pictures. This picture stands out to me as one that would be a rotation. If I had my patty paper, I could trace R and hold it on the origin and start rotating. And then this, as I rotate, this would point downwards. I could also go get one of my coordinates. This coordinate is 1, 2, for instance. And I can see that if I flip-flop this, if I do the rule to it, if I take my 1, 2, and I do my rule, I should get 2, negative 1. Well, if I look at my graph and I go over 2 and down negative 1, I can see where my point went as I did that rotation of 90 degrees around the origin. So it looks to me like 2 went with A, and this was number 2. So now lastly, it looks like 4 should go with C. So let's check that out. This should be number 4, and this should be C. So it looks like my x coordinate, which was 1, I took 1, 2, 3, 4 away. And my y coordinate, which was also 1, I took 1, 2, 3 away. And I get to my new coordinate on my image. And so this one would go together. Lastly, the one that they had the mistake with, I would like you to notice that in number 3, they multiply the x term by 3, but not the y term. And so they were trying to get you to realize that once that transformation would have been done, it would be neither similar nor congruent because you changed the x coordinate by multiplying by a number that you did not to the y coordinate. That brings me back to 2 and 3. This was a rotation, so this guy would be congruent because that is a rigid transformation, and this was a translation, so the two figures would also be congruent because that is a rigid transformation. Thank you. So let's take a look at page 26. On page 26, we have 2 problems done for us. Number 1 says, write the rule that'll transform our little blue triangle ABC to the bigger triangle A prime. So this is page 26, 3.3. You write the rules. So let's take a look at questions 1 and 2. 1, it says, write the rule that will transform triangle ABC, our blue triangle ABC, to triangle A prime, B prime, C prime, the green one. And it says, are A, B, C, and A prime, B prime, C prime congruent, similar, or neither? Explain how you know. So looking at this transformation, I can tell when I look at it, they are not congruent. They also don't look like they might be similar. I'm not sure this looks twice as big or not. So why don't we look at the coordinates and see if that will help us? So just like when we make a table, in the first 2 lessons, we would have our XY column, and then we'd have our other column. Let's look at our 3 coordinates to help us make a decision. So for example, A is 2, 3. B is 5, 4. And let's see, C is 3, 4. Okay, so let's see what they were transformed to. So B prime looks like is at 5, 8. C prime is at 3, 8. And A prime is at 2, 6. And I want to try to figure out how those coordinates changed. You don't have to make a table, but since I already have created one here, why don't I set these up in a table? Then it'll look a little bit like a homework problem actually. And C was 3, 4. And then A prime became 2, 6. B prime became 5, 8. And then C prime became 3, 8. So I'm looking at these coordinates and I'm trying to determine my rule. What was it that I did to this? Well, if I look at this, my x coordinate stays the same, and it looks like my y coordinate doubled. So it looks like this is x, comma, 2y. So let's write that in for number 1. The rule was xy became x, comma, 2y. So this asks, are they congruent, similar, or neither? So they are not congruent. This is not a translation. This is not a rotation. This is not a reflection. They are not the same size. They are not congruent. They're also not similar. I didn't change both my x values and y values by the same number. In other words, I didn't double x, multiply it by 2, at the same time I doubled y. So then they are not similar figures. So they would be neither. So let's take a look at 3 and 4. For 3, it says, write a rule that will transform triangle DEF to D prime E prime F prime, and are DEF and D prime E prime F prime congruent, similar, neither. So let's take a look. If you notice on the blue triangle, DEF, I have labeled their coordinates. So for D, it's negative 2, 1. For E, it's negative 4, 3. And for F, it's negative 6, 1. So let's do the same thing for the image. So D prime is negative 2, and then it's down 1. E prime is negative 4, and then it's down 3, negative 3. And F prime is negative 6, and then it's down 1, negative 1. You're welcome to put this in a table like we did the first problem, but are you noticing what's going on here? In all of these, my y value is the opposite. My y value is negative. And this is a reflection in the x-axis. And we have done that in lessons 1 and 2 already. So you might have looked at this and realized that to be a reflection in the x-axis, my coordinate xy has to go to x, negative y. So in this problem, it asks if they're congruent, similar, or neither. They are congruent. It's a reflection in the x-axis, so the triangles are congruent. Technically, they're also similar in the sense that the scale factor would be 1, but more importantly, they are congruent to each other. They are exactly the same size because they are a reflection in the x-axis. So then this brings us to the summary. You might want to take a look at this page. They have a rotation that you can take a look at. Then they also have one that is neither a rigid transformation nor is it a dilation because my y values change by 3 times while my x coordinate doesn't change at all. So you could take a look at this example for more help if you would like. At this time, I'd like you to take a look at the practice 3 problems. I'm going to assign all the problems in practice 3 for you to do, and there's a separate video on the practice 3 problems if you'd like a little help as you go through them. Thank you very much.